Okay, so we almost finished yesterday, but we barely didn't, so I'm going to do it real quick. Okay, I'm plugging in 3y over 2. Okay, for x. Okay, shh. 3y over 2 is going in for both of my x's. Okay, now there are multiple ways for you to solve this. So if you solved this for y yesterday, you're not wrong, but your answers are going to come in a different order. Okay, so I'm solving for x, I'm substituting. So what is 3y over 2 if I square it? You got to square the whole thing, top and bottom. Square. 9 over 4 y squared. That's how I'm going to write it. That's the same as 9y squared all over 4, depending on how you look at it. Okay, next term is a 4y squared. Then a 7. Okay, then over here, what do I have? 3 times 3 is 9 over 2y. And then if I have a y times another y, that's also a y squared. Good to there? Okay, then I have several fractions, okay, and they have different denominators. What could I times by that would kill off both of those fractions? If I times by 2, okay, yeah, so if I times by 2, it'll only cancel out this one. Shh. So I'm going to times by 4. But remember, when you use that method, you have to times by 4 all the way across. I'm timesing by 4 to get rid of the 9 over 4. So when I do 4 times 9 divided by 4, what happens to the 4's? They go away, and I just have a 9y squared. Okay. Then 4 times 4y squared, what do you get there? Thank you. 16y squared. What about 7 times 4?
28.
And then 9 times 4 divided by 2. What's 9 times 4? 36 divided by 2? 18y squared. Okay, from there. Shh, shh. Okay, combine like terms. What are these together? How many? 25y squared. Okay, then I have equals 28 plus 18y squared. Next step, bring your little 18y's over. Okay, how many are left? 25 minus 18 is 7y squared equal to 28. Divide by 7. Y squared is what? 4? We had a 28 because we times the 7 by the 4. And then plus or minus 2. Root.
Easy.
Marco, did you figure out your question?
Yeah.
Okay, cool. Now, from there, it said to find the points. If I say y is 2 and negative 2, are those points? No. Where can I go back to find the other half? Go back to your x equals. So I'm going to put when y is 2, x equals, and then I'm going to go back to here. If it's 3y over 2, well, that's 3 times 2 over 2, which is 6 over 2, which is 3. So my point is 3, 2. Okay, then what was my other y? 2 and negative 2. And if y is negative 2, then what's x? 3 negative 2 over 2. Negative 3. So my ordered pair there would be x equals negative 3, y equals negative 2. Make sense? Okay. So if you did it backwards and you solved, you would have gotten x equals plus or minus 3. And then you would have had to go back and find the y's for plus and minus 2. But either way, you get the same 2 points. Make sense? Okay. So we are going to add a little bit of new stuff today, which I bet you're really excited about. But we have to finish one more kind of regular problem with trigging it before we get to that. So turn the page. Look at the top one. Okay, right here. We have 2y equals x squared plus sine 2y. Okay, take the derivative. What do we get for the derivative of 2y? 2 dy dx equals derivative of x squared. Okay, now I get to sine 2y. What's the derivative of sine? Cosine 2y. Then I need to times by the derivative of the core. 2 dy dx. Very good. Now, that's on the wrong side. Remember, your dy dx's always have to go left. So if they start off on the left, you leave them. But if they start off right, you have to switch them over. And when that moves over, it's going to turn to a negative, yeah? So I'll have 2 dy dx minus, and then instead of keeping it in this order, I'm going to let that 2 that's kind of in the middle here move in front. So it'll be a minus 2 cosine 2y equal to the 2x already across. Now, someone from the other class is like, why can't I just times it and make it a 4y? No. 2y's in the trig. You can't do that. Okay? Just like if it was in an ln or something, you can't distribute into those. Not a thing. Okay, from there, they both have a dy dx. So I'm going to pull that out. What's left over? Okay, and where is that going to end up on the bottom? So I'm going to kind of skip a step. Hopefully this doesn't confuse everybody. But when my dy dx comes out, this is left over, and then I divide it down here. So it'd be 2 minus 2 cosine 2y. Are you all okay with me skipping that? Okay. Huh? Yeah. Good. Okay, now how do I make it vertical? Okay, very good. Remember that a vertical tangent is an undefined slope, and an undefined slope means that the bottom has to equal 0. Now, your bottom has trig in it, but this has been in your homework a bunch of times. So, if you're actually doing your homework instead of copying off of your neighbor, then this is not the first time that you've done this. Okay? So, you're setting it equal to 0. I'm going to add my 2 cosine 2y across. Then divide by 2. And what does cosine 2y have to equal? Oh, why is there another equal? Yeah. Oops. Okay, it has to equal 1. Very good. Okay, now from here, I want you to think about what angles is cosine going to come out equal to 1. Okay, very good. Now, somebody in the other class said, okay, when cosine is 0, pi, and 2 pi. Here's the problem. At 0, what's cosine? At pi, what's cosine? Not what I want. I don't want negative 1, I want 1. So I have to cross that out. That actually doesn't count. For 1, I have to consider the sign. So 0 and 2 pi are my guys. What does y need to be so that this will come out to 0? Okay, y can be 0. What does y have to be so that the middle comes out to 2 pi? Y has to be pi. And does it make sense why I'm not picking 2 pi? Because there's already a 2 built in. So if I pick pi and I plug it in, then it becomes a 2 pi. Cosine is 1 like I want. Good?
Awesome.
Okay, perfect. All right. Yes, it is. Okay. So the next 2 questions, look through them. What is the new thing? Look at 11.
Double derivative.
Double derivative. Okay, look down here. We're getting there. Okay, so in order to take the second derivative, though, you have to take the first derivative. So look at your equation, xy cubed. Okay. We're going to do product rule. What was your question, Anisha? Okay. So my u is going to be x. My v is going to be y cubed. So what is u prime? What is v prime?
3y squared dy dx.
Good. Okay, set up your product rule and then just kind of like solve it all the way through. So you'd have 1 times y cubed plus x times 3y squared. You can rearrange that dy dx equals 27. 0. Remember, it's the derivative. Then from there, I have only 2 terms. One of them has to move because it's missing the dy dx. So my y cubed is going to come over here. So I have 3xy squared dy dx equal to negative y cubed. From there, what? Divide by 3xy squared, divide by 3xy squared. So from here, my dy dx is negative y cubed over 3xy squared. Okay, now, question. I can leave it like that. That's fine if I want to, but if it can simplify, especially if you're going to have to take a second derivative, I would do that. So what do you notice is on top and on bottom? Yeah, you got some y's that can cancel out, right? So if I have 3 y's on top and 2 on bottom, after I cancel, how many will be left? 1. Where will it be left over? Yeah, negative 1y on top and then a 3x on bottom. So I'm going to cancel the extra y's to give me that. Okay? Alright, so go to part B. We know that y is 3. We need to know the other half of the point or we can't find the slope. So if y is 3, go back to here. Remember, xy cubed equals 27. Well, then x3 cubed is 27. Well, 3 cubed is 27. So if 27x is 27, what's x? 1. And remember, just because that point has a unique xy doesn't make it a function. That would have to be true for every point. So my point now is 1, 3. Okay, part C says to find the slope of the point. So I put dy dx, vertical line 1, 3, equals. And then I'm plugging into my little formula. So y is 3, negative 3 over. 3x is 3 times 1. What do you get for your slope? Good. Okay, now, the second part C, because I forgot to re-letter it, should be part D, is the second derivative. So, what I need to do now is take the derivative of this again. What rule is that going to need? Quotient rule. Very good. So, I need to take the derivative again. And I'm going to need quotient rule. So, let's review how to do quotient rule. You need to do your high and your ho. So, my high is negative y. My ho is 3x. What is d high?
Is it positive?
It'd be negative 1.
dy dx.
Good. Okay, so derivative of minus y is minus 1, and then dy dx. Okay, then for 3x, what's the derivative of that? 3. Okay, let's do our ho d high. So these two first, minus high d ho. So it'll be negative 3x dy dx minus high d ho is negative y times 3, so that's a negative 3y. All divided by ho squared is 3x squared. Okay, what did I do wrong? Parentheses. Remember, not just the x is getting squared, the whole 3x. Okay, and then also I need to label this d squared y dx squared. Yeah? Okay, now let's look at our equation. This is the second derivative at any point. When do I want the second derivative? At my point, 1, 3. So I'm going to plug in. What letters do you see we're plugging in? X is, y is 3. What is dy dx?
Oh, it's that thing.
Yeah, you just found it. So when I plug in, you have 1, 3, those are your x's and y's, and then your dy dx is negative 1 from the previous part that we just did. So when you're plugging in, you're actually subbing in for 3 different things. But you already know them because you already found them. So let's do it. Now, your notation is pretty similar. It'd be dy dx squared at, and then 1, 3. Okay, just like that. And now we're just plugging in our stuff from there. Now this minus negative, is it okay if we switch that to a plus? Okay, that's really just a plus there. So I have negative 3 times x. What's x? What's dy dx? Plus 3 times y is 3. On bottom, 3 times x is 3 times 1. And then I will square that result. So on top, negative 3 times negative 1, what do we get?
Negative 3.
Positive or negative?
Negative first, and then, well, positive.
Yeah, it'll turn positive, right? And then 3 times 3, there's a 9. 3 times 1 is 3 squared. So I get 12 over 9. Can that reduce? To 4/3. Now, this is the sign of the second derivative. What is the second derivative in charge of? Concavity, or which concave direction it is. So if my second derivative came out to be positive 4/3, what's my concavity? Okay, this means that the graph of y, the original function, is concave up. Okay? So you should be able to put this kind of back into the context of first and second derivative test. When I take the second derivative, that tells me concavity. So if it comes out positive, my graph is concave up. Now, just kind of as an aside here, what about if I had a tangent line on a concave up graph? Where would the tangent line fall? Above or below?
Under.
It would be an underestimate. So I would start thinking about that when you test over this. That question is also on there. Okay?
Wait, just to make sure, in general, concaving up means it's going to be an underestimate, and concaving down is going to be over.
Yes. When it's concave up, your tangent line is under. And then when it's concave down, your tangent line's over. Okay, turn the page. Okay, you're doing A, B, and C on your own for this one.
Yeah, cookies?
Yeah, okay, fine. But I don't have cookies, but I have the mix, and then I have candy.
Yeah.
Assorted. Okay. Okay, but you're doing it. You will do it. Dang, this came for you, but I feel like you should go through.
Oh yeah, after class, right?
Yeah.
That's perfect.
Why are you doing that?
Closing?
Yeah. Oh, I do have some of the duos. Okay, we're not gonna make phone calls.
That was Krishna. That was Krishna. Krishna, the god.
Don't bully her.
Who is good?
Anna was here.
Where's Kaylin? Which one did you try it?
You had a phone on
So
silent.
good. I think it was the powdered one, right?
So how would it? So good.
Try it.
You go back to lava.
You like it? What does it taste like?
Does he go? What?
Donuts?
Yeah.
Are you filming? Are you grabbing?
It's just like a snake noodle with like donut.
You're welcome.
It was too much in my hair.
Yeah, you're doing it, dang, and I know you're not doing it.
Are you sure that's your phone?
Oh, there is one Oreo.
Is that yours,
The
bro?
bottom right there. Oh, there is only one. That was one.
It was pretty funny, but it was so hard.
Try it. Yeah, you're doing it, doing the problem.
Shut up, man.
Eating the cookie is a binding contract to work. What is that?
Thank you. Thank you very much.
You're so welcome.
Oh, Krishna, get one for me, please.
Cookie?
Oh my god. You're the best cookies I've ever had.
Yeah, so we're gonna pop it today? You and me, Eli, Tion, on the first time.
Bro, 5 people I give
You
this
got your
last
nose out. You're doing
I
better.
saw what? That's
How
what
about sandwich?
Oh. Do you want another packet? We can just stick them together.
What the? What is happening?
Yeah, they're on, they're right by that pink crate. Because we're also going to do some of the homework. And if you look, the notes and homework are right next to each other. You want one? You want one?
Yeah.
Delicious cookie. Cookie time?
Hey, you homework on that photo on your story.
Why? It's on my private.
No.
But I don't know how to create that.
You want a cookie?
Ah, you are.
Just lit up,
No, you
bro.
want one?
Yeah.
I think I ran out.
Bro, you're having so hard. Hey, you're having so hard.
Hey, Wilson, come on, you her.
Yes, ma'am.
Marco, did I give you one?
How are you a drum major?
Got it! You don't have an excuse like that.
Hold up. What was your grade last year in pre-cal? 100.
Your grades are
103. I had 100. I averaged 100.
So what you're gonna do is
At the very end of the last quarter.
Whoa!
So go ahead and plug it in, solve it all the way out, and then that'll help you pick which answer you want.
Hey, it's only James saw that you graduated.
Yeah.
It's stupid.
I know. Wait,
So this one needs a dy dx on that.
Yeah.
Remember,
Oh, you're
when
old,
you take the
bro.
derivative of a y thing, you put a dy dx on that. So then
I'm not gonna do
this
it. I'm not gonna
diagonal
do that. Then you
with
get
the
picked
8
up
in it
by
should have a dy dx
I
on
look
it.
wrong here.
And then from
Oh,
there,
yeah,
this
you
one
are.
that doesn't have the dy dx will have to
Literally
get
one
minus
left.
across. So
Yeah.
that's
That's
equal to
right.
negative 4x to blah blah blah.
Running out of time.
Where did we?
Okay, were you supposed to be doing product rule on this? No, if you did product rule, I don't know how.
Yeah.
Actually, I'm just realizing, is that what you did, Brianna? Is that product rule? Or Josie, did you do product rule?
Shut up.
Oh, it was you, okay.
Oh, it's the money
These are
around.
cells, they're not multiplied. So you're just gonna take the derivative. You don't have to do a product, because it's not like 2x times y to the 4th. Does that make sense? I didn't even realize that until I walked away. What, yes? Yes. Okay. What is the derivative?
Negative 4x over 4y.
Okay.
You might do mine.
Okay, 4x plus. Derivative of y to the 4th is 4y cubed. So 4x plus 4y cubed dy dx equals 0. That comes across. So you have 4y cubed dy dx equals negative 4x. Then divide by 4y cubed on both sides. So I have dy dx equals, now question, anything that can cancel out to make your life simpler?
4.
Okay, the 4. So really it's just negative x over y cubed. Now remember, your first one's not wrong, but that just makes it easier. Okay, part B, we want the equation of the tangent line where y is 1. Then we're coming back to here. So I'll have 2x squared plus y is 1 to the 4th equals 9. Well, 1 to any power is still a 1. And how do I get rid of a 1? I subtract it. Very good. So I'll have 2x squared equals 8. X squared equals 4. Divided by 2 on both sides, which means that x equals plus or minus 2. Now, this is where the quadrant comes in. If I want to be in the first quadrant, what kind of x do I need? Positive or negative?
Positive.
Okay, very good. Your quadrants are 1, 2, 3, 4. So if I'm in the first quadrant, I need to be here. Then I need x to be positive 2 and y to be 1. That would put me like up here somewhere. Okay? So what do I need besides the point? I also need the slope of the tangent line. So I need dy dx at 2, 1. Okay, well, my equation's right above that. I need negative x, which is 2, over y cubed, which is 1 cubed, negative 2. That's my slope. So I'll have y minus 1 equals negative 2, x minus 2. Everybody good to there? Okay, part C, do we need to do it, or are we good? You just plug it in, do the things. Okay, alright. Oh, okay. Okay, do it for fun if you want. But part D is where we have new stuff, so let's go to that. Okay, so part D, I need the second derivative. What rule do I need to use on this guy?
Product. Or quotient.
Quotient, very good. So the high is going to be negative x, and the whole is going to be y cubed. So d high is what?
Negative 1.
Okay, I think I said that wrong, but you know what I mean. Okay, d high is negative 1. What's d ho?
3y squared dy dx.
dy dx. Okay, then from there, remember, it's ho d high minus high d ho. So this guy goes first. Multiply those together, what do you get?
Negative y cubed.
Negative 1y cubed minus. Then I need high d ho. So that'd be negative x 3y squared dy dx over ho squared is y cubed squared. Okay, then from there, that is d squared y dx squared at any point. But I want it at my point, so what are the three things I'm plugging in? My x is a 2, my y is a 1, my dy dx is a negative 2. And you got to have all three of those things to plug into. Okay, make sure you change your notation. So it'd be that at 2 comma 1. And then now we're plugging in. So it's negative 1 times 1 cubed plus, because of the double negative. Then my x is a 2. Then times 3. Then times 1 squared. Then what's my dy dx? Negative 2 for that. Okay, then all over. My y is a 1 cubed squared. So, negative 1 times 1 cubed is just a negative 1. Okay, then I have 2 times negative 3. What's that? Negative 6 times 1 squared. Okay, that'd be still negative 6 times negative 2 is plus 12. Oh, is that a times?
Yeah.
That's a times, so actually it is a negative 12. Sorry, I saw my little times dot as a negative. Okay, then from there, I have 1 to any power is still a 1. So what's negative 1 minus 12 more? Negative 13. Now question, if my second derivative is negative, what's the concavity for the original graph? Okay, so I'm going to put here, that means y graph is concave down around the point, what was it, 2, 1. Okay? So my original graph must have been concave down or the second derivative wouldn't have come out negative. Okay? Alright, last part. Look at the difference between D and E. D asks you for the derivative at a specific point. So the answer is going to come out to be a number. Okay, this says in terms of x and y. What that means is that you need to leave it as an equation with only x's and y's as your variables. So you cannot have any other letters. So look back at my original equation. What letters in here are not allowed? The dy dx can't stay. So what I want you to do is write d squared y dx squared. And I want you to write out the whole same formula, but when you get to this dy dx, I want you to just leave a parentheses. So it'll be negative 1y cubed plus 3xy squared blank, and then over y to the, what is y cubed squared? 6th. Okay, because remember it's like y3 but twice. So I'd have 3 and then 3 more makes 6. Okay, what could I put here in dy dx's spot that has x's and y's in it? Okay, the negative x over y cubed, remember? So if I want to go back to x's and y's, I can't call it dy dx, I have to go back to this. So I would just plug in a negative x over y cubed. And that would be considered in terms of x and y. That's what that means in terms of x and y. Now, can that term that I plugged that into be simplified? I see y's multiplied and y's divided. So how many y's really belong in that term if they wanted to make it a little harder? Only one, and where should it be for that term? On the bottom. So you'd have negative y cubed. Okay, 3 times negative x times x is negative 3x squared, but then only one y on the bottom, and then a y6. So if it was multiple choice, they would almost for sure do that. They'd see these x's together, make it an x squared, and then they'd see those y's together, and just leave one y on the bottom instead of in both places. Hello? It is.
Because of the negative x in parentheses.
Mr. Vong?
Oh, that's me.
What? Is that a student? Vong?
This one.
Is Miss Wong?
She has a phone. How can you?
Is it? Oh,
How can you?
oh.
Negative x in parentheses.
Are you thinking of Fung Win? No, I'm not. But I mean, I know the math teachers. There is a Fung Win, but Fung is his first name.
Oh, I know him. He's big.
Okay, sorry. Okay, fine. Is there a Mr. Vung here? Or Vong?
It's actually.
Okay, you get it? You get it? Yeah? Okay, get out your homework.
What?
We're gonna do some homework questions. Okay?
Jokes on you, I
I want a
finished.
challenge.
it better be perfect,
Got a couple of pages here.
Better be what?
perfect, please.
Oh yeah, we can do, I was thinking maybe 12.
Oh, yeah.
Well, questions or number 2?
Number 12. We won't get through 12. We can, so in the other class we got through 12 and 13. So you'd have that whole page done.
Keep writing, we'll keep writing.
No, that's not how it works.
Tell
Okay.
him. Okay, love it, winner.
Yes, let's go. Okay, number 12. Who's gonna do it? You!
Oh my god. My eyes are burning.
Ah.
Soldier boy says you! Okay, do it. Let's go. I did call you.
Yeah, we're doing it together.
Hit me, bro.
What?
No, I'm
Yeah. Okay, what rule do you need? Products. Okay, and I'm gonna do it on the board. Oh, but I'm videoing. Okay, so do it.
I'm on Earth, bro.
Krish.
Yeah.
Do it, Chris. Good lord, man. She what?
She what? He just said a
Change the
word.
subject. She did not do her math homework for you? Good.
Boy, you gonna... Miss Runner, that just means that she talks.
Yeah, I know.
Got it.
I don't live on here on my music.
Yeah.
Oh. My eyes are burning.
From my Soldier Boy dance. I used to know the whole thing.
That's awesome.
No. Did it in the pep rally at my old school. We had like a teacher dance. It's pretty lit, you might say. Okay, what'd you get?
I have the band perform Soldier Boy. See what I get?
Okay, u prime would be 8x cubed. V prime would be 2y dy dx. Yeah, so far so good. Okay, so then I'll have 2x4 2y dy dx plus. Other side I'll have 8x cubed y squared equal to what? 0. Okay, from there, what's moving?
2x4
8x
cubed.
Y squared.
This one. Why? Because it doesn't have a...
DYDX.
Good. So I'm going to have a negative 8x cubed y squared come across. Okay, and then my 2 times 2, I'm going to collapse that into a 4x fourth y dy dx, and then that's going to end up getting divided. So I'll have a 4x 4y on the bottom.
And we can cancel y.
Okay, I can cancel y's, I can cancel x's, and I can divide those numbers, so you should do all of that. Okay, so let's reduce. Negative 8 divided by 4 is negative 2. Where does my x stay?
Bottom.
Okay, where does my y stay?
Top.
Okay, very good. Second derivative, what rule do you need?
Second derivative.
Yep, for part B. So this is done for part A. Oh wait, crap, no, we need to plug in the point. Okay, so we still need to find dy dx, my bad. Okay, so I need dy dx at 1, 4.
What was that? What do you want to do?
Well, I need it at the point, and I forgot to plug it in. Now notice, this time they gave you the entire ordered pair. So that cuts out a step, right? I don't have to find the point, they just gave it to me. Negative 8. Okay, so I have negative 2 times y over 1, negative 8. Okay, now let's go to part B. So for the second derivative, I need to use quotient rule. What is the high? Negative 2y. What's the ho? X. What's d high? Good. What's d ho? 1. From there, we're going to do ho d high minus high d ho. So second derivative, d squared y dx squared equals ho d high negative 2x dy dx minus high d ho is negative 2y times 1. That's really just a negative 2y. Ho squared is x squared. From there, we're plugging in our ordered pair, which is what? 1, 4. What's our slope at that point? Negative 8. So it'll be d squared y dx squared at 1, 4 equals. And then you're plugging in. So it'll be negative 2 times x. dy dx is negative 8. Oh wait, and then what mistake did I just make? Double negative, what can happen here? So really that's a plus. And then 2 times y is 2 times 4. All divided by x squared, x is 1 squared. So on top, I have 16 plus 8. How much is that? Or wait, yeah, right? 24. Overall, what's your concavity? Up. Positive. Good. Okay, part C. What do I change to make it in terms of x and y? That has to switch. What do I switch it for? The original derivative that I had. So in terms of x and y, it would be this. Negative 2x, big parentheses, plus 2y over x squared. And then right here, where my dy dx is, I'm just subbing that out for the equation. So this is switching in for this here. So it'll be a negative 2y over x. Now, remember what we said. If this is free response, that's good enough. But if it's multiple choice, what could they do in there? Yeah. Okay, so negative 2 times negative 2 is what? Positive 4. And what's going to happen to the x's if that one's on top and that one's on bottom? Those are going to cancel out. So that's really just a 4y plus 2y on top over x squared, and then those become like terms. What's 4y plus 2 more y's? 6y over x squared. Make sense? But if it was free response, do not waste your time doing all this crap. You only do that if you absolutely have to because it's multiple choice. Okay?
Okay.
And usually, they're going to have you find it at a point. Okay, but this is on there sometimes. Okay, we only have 2 minutes, so. Good. You've had this homework for a few days. How's it going? Making progress. I'll be here till 5 if you need any help.